In the last class, we were talking about chemical reactions and equations. Of course, we have started the chapter talking about physical and chemical changes, their properties, examples, isn't it? And after learning them, after learning chemical changes, we started to understand the characteristics of chemical changes. What are the characteristics? Like, chemical changes involve liberation of light, heat, and sound energy commonly. And in many cases, chemical reactions will also evolve gas. So evolution of gas is also one characteristic of chemical change. That's good, Samyukta, keep responding. And rest of you also, you can please respond. Yeah. Well, other than this evolution of gas, sometimes precipitate will be formed. And other than these changes, we might also notice change in color, change in taste, and change in smell as well. These are the characteristics which are commonly exhibited by chemical changes. It's not necessary that one chemical change should exhibit all these properties, but then one or two of these properties are definitely exhibited. And one most important and common feature of chemical changes is formation of new product, right? And of course, after learning this, we have discussed activity 1.1 and activity 1.2. Activity 1.1 was about burning magnesium ribbon, where magnesium is burnt in presence of oxygen to give magnesium oxide. And activity 1.2 is when zinc granules were added to dilute H2SO4, and it leads to formation of zinc sulfate, and of course along with that hydrogen gas is liberated, right? With the help of these two examples, we have concluded that chemical changes would be exhibiting these properties, right? And the observations of these two these two examples were magnesium, liberation of heat, light, and formation of a new product, and zinc plus H2SO4, evolution of a gas that is hydrogen along with liberation of heat. We could observe these things when practically we perform these activities. This is what we have done in the last class. Guys, those who joined new, who are taking the class for the first time, please play the recording of my previous class and watch the session, yeah, so that you'll get in sync with the flow. Yeah. So is there anyone in the class who has a doubt so far? Is there anyone who has a doubt about what I have written on the screen or what we discussed in the last class? Is there anyone? Guys, if you don't have a doubt, say no at least. Okay, that's great. Janvi has no doubts. Well, Samyukta, Niharika, Banu, that's great, my dear students. And I believe you have studied after the class. Did you? Guys, did you study after the class or just you studied, right? Remember, after each and every class, you have to study. That's the only way that you get chemistry easy. Yeah. Now, hello Arman, welcome to the class. Well, let us begin with today's class. In today's class, what are we going to do? We are going to continue the same topic, but then of course as an extension we are going to study about chemical equations. But then what's the difference between chemical reaction and chemical equation? Chemical reaction is when you are talking about a chemical change. A chemical reaction is when you talk about or when you explain the change which is happening chemically. For example, take the example of magnesium ribbon. You have taken magnesium ribbon, cleaned it and burnt it in presence of oxygen, as a result of which you had some ashes coming up, some new material or some new product coming up. So you are explaining the chemical change here. This is nothing but chemical reaction. But if you have to put it on the paper, if you have to write it down, always it's not so easy that you go on writing magnesium and oxygen, burning in presence of oxygen. Isn't it too long? Yes or no? Yeah. So because it is too long to represent chemical changes in word form, to avoid wastage of time, to avoid wastage of paper and wastage of energy, in fact, to study the chemical changes more easily, we have a way. We have a shortcut, and that shortcut or short way of representing a chemical change is nothing but chemical equation. So chemical equation is a symbolic representation, whereas Chemical change is representation of a chemical reaction. You see something on the screen right now. This is what we have spoken in the last class, right? Magnesium plus oxygen leads to formation of magnesium oxide. In spite of writing all these words, we can simply use the symbols and write it as magnesium, that is Mg, plus oxygen, that is O2, give after reaction magnesium oxide. So now observe which is easier to write, which is easier to study and understand. Obviously the shorthand notation or the symbolic representation, right? That's why chemical equations are used. Yeah, right? Most of us would be having some nicknames at home. How many of you do have? Do you have a pet name or nickname at home? How many of you do have? Okay, Sadhana has, Niharika has, Kanishka has, Vaishnavi has, Anirban also has. Many of you. Anirban, by chance did you attend any of my webinars or something? I find your name a little familiar. You said you joined the class for the first time today, but still I find your name a little familiar. I don't know why. Yeah? Yeah, that's the thing. You have attended some of my webinars or other sessions, I believe. That's great then. Well, the way we have nicknames, all the elements and compounds have symbols. Using those symbols, if we are writing the chemical change, we call it as chemical equation. How do we actually define chemical equation? Chemical equation is nothing but the symbolic representation of a chemical change. But how do you write the chemical equation? Are there any rules that we write the chemical equation? Or are there any points that we should understand about it? Yes, there are a few points. Point number 1. Guys, I hope you all know when you maintain a running notes, it gets easy for you to understand and remember things. Yeah. So I hope everyone in the class is maintaining a running notes. You don't need to buy a special notes for it. At least a rough notebook will do. Yeah. That's great. So chemical equation, characteristic of the chemical equation, or the points that we should know about chemical equation are being listed down here. Yeah. Point number 1. Every chemical equation will have two sides. One is left hand side, that is on the side of your left. Other one is right hand side, of course on the side of your right. What is this left hand side and right hand side? Left hand side in short written as LHS and our right hand side is RHS. I hope we all know this. Let us take one example of an equation and study about this LHS and RHS. Same example would be good, I believe. Mg plus O2 gives MgO. For this chemical equation, observe, in between the symbols there is an arrow mark. In between the symbols of the reactants or symbols of the elements, there is an arrow mark. So break the reaction with the arrow mark. Whatever is there on the left hand side is called as LHS materials and right hand side RHS materials. Whatever you have on your left hand side are called as starting materials. They are the ones who are starting reaction, and they are technically termed as reactants. So on which side of chemical equation do we find reactants? On the left hand side. And how about the other side, the right hand side? Right hand side has the ending materials of the reaction, and the ending materials technically are called as products. So every chemical equation has reactants on the left hand side and products on the right hand side. What are the reactants in this particular example that we have taken? Anyone in the class, please? What are the reactants in this example that we have taken? That's good. Samyukta is the first one who responded, and then is Aglu, and then Vaishnavi. Very good, my dear students, very good. We have magnesium and oxygen. They are the reactants, and the products are magnesium oxide. We have only one product. Point number 2. Point number 2 is that both the reactants and products are always separated with the help of an arrow mark. The head of the arrow mark should be towards the products and the tail of the arrow mark should be towards the reactants. Right, guys? Always reactants and products are separated with the help of arrow mark. Now, since we are talking about the arrow mark, let me tell you one more point which is important. On the arrow mark, you can write the reaction conditions like pressure, temperature, or energy sources, or sometimes some other reaction conditions. For example, magnesium plus oxygen are burning, right? we are burning. What is the reaction condition? It will not happen until and unless you burn it. So on the arrow mark, you can write that. You can write that you are burning it. And for burning, there is another symbol, that is delta. I'll tell you about the symbols in a while. Okay. So the arrow mark would be including factors such as pressure, temperature, energy, sometimes catalyst, etc., etc. Okay, it's very, very important, remember. And if you are worried what is meant by the term catalyst, catalyst is something like boost to the reaction. It will speed up the process of reaction. Yes guys, are we clear? Are you all able to follow? We are talking about characteristics of a chemical equation. The first one is every chemical equation has two parts, left hand side and right hand side. The second one is both left hand side and right hand side are separated by means of an arrow mark, and of course on the arrow mark the reaction conditions like pressure, temperature, energy, catalyst are written. Now point number 3. Point number 3 is, this is also one important point. Now observe the same equation. Magnesium plus oxygen leads to formation of magnesium oxide, okay, in presence of heating. Now, looking at this chemical equation, is there any way that you can tell me the physical state of magnesium, physical state of oxygen? Can you tell me, looking at the equation, not by using your knowledge, just looking at the equation, can you tell me this? It's not possible. Magnesium is solid, we know it because we have studied the activity. Oxygen is a gas, we know it out of our knowledge, right? But literally, just looking at what is written on the screen, we cannot justify if magnesium is a solid, liquid or a gaseous material, isn't it? So this is a drawback of chemical equation. In olden days, people were not using the physical state along with the chemical equation. But now, what we do is we have an addition. The way we have extensions for Chrome browser, we have extensions here as well. And the extension about physical state is whenever you are writing the reactants or the products, soon after you write the symbol, you have to represent the symbol along with the physical state. For example, magnesium, what is the physical state of magnesium? Solid. Use our knowledge to write the chemical equation. Physical state of oxygen, gas. Physical state of magnesium oxide, solid again. Isn't it ash? Ash is solid, correct? So this way, physical state of the reactants and products always should be written in the brackets. This is also important point. Keep it in mind. So now we have an extension of the physical state. So looking at the chemical equation, we can say that yes, magnesium is solid, oxygen is gas, and MgO is solid, right guys? This is the third point. In the chemical equation, we always should represent the physical state of matter, right guys? Now, let's get ahead with the fourth point. Fourth point. Yes, I told you about the symbols, right? When you're heating, it is delta. Let me tell you a few more symbols. In case the reaction condition is heating or burning, the symbol is delta. You call it as delta. And then, in case there is some gas evolved during the reaction or as the product, whenever there is a gas evolved, you use an upward arrow mark. For example, say, we have dealt with one example, right? Zinc plus H2SO4. As a result of this, the products were zinc sulfate plus hydrogen gas, right? So this hydrogen gas is evolved here. Whenever there is evolution of gas, you can use an upward symbol right next to the gas. This is a symbolic way of representing evolution of a gas, right? So the second symbol is upward arrow mark, and then there is one more symbol, and that one more symbol is downward arrow mark. Downward arrow mark is represented whenever there is a precipitate formation. PPT is a short form of precipitate. It is not PowerPoint presentation. It is PPT, precipitate in chemistry. Yeah. And what is precipitate? Precipitate is nothing but some insoluble material which is formed after the reaction. If there is some precipitate formed after the precipitate, you represent a downward arrow mark. Yeah. Right, guys? Yes. So these are the characteristics of a chemical equation. The first one, LHS and RHS. Second one, the arrow mark. Third one, is about the physical state. Fourth one is about the symbols. Is there anyone in the class who did not understand or who has a doubt? Is there anyone? I'm talking about types of chemical equation. Types of chemical reaction is different. When we are talking about equation, we are talking about the way, the symbolic representation. Yeah. So, how many types of chemical equation do exist? Right? Now, let me take one other color to explain you this. There are two types of chemical equations. I repeat guys, chemical equation is different and chemical reaction is different. Right now we are talking about types of chemical equation. There are two types of chemical equations. The first one is a chemical equation which is raw, which does not follow any rules in the universe. It can exist as it wants. Basically, all the chemical equations in the universe are expected to follow a law called as law of conservation of mass. How many of you know this law of conservation of mass? How many of you know this? In physics we have studied, yeah, mass can neither be created nor be destroyed. The same thing applies to the entire universe, not only to physics or chemistry, but it is applicable to the entire universe. So based on law of conservation of mass, if you have an equation which is following law of conservation of mass, you call it as very ideal equation, and technical term for that is balanced chemical equation. The technical term is what? Balanced chemical equation. What is balanced chemical equation? It's an equation which follows law of conservation of mass. But what do I exactly mean by an equation which is following law of conservation of mass? How do I put it into practical help, or how do I put it into practical terms? Simple. We have studied about two things, right? Left hand side and right hand side. Yeah. If the number of atoms on left hand side is equal to the number of atoms on right hand side, you call the equation as balanced chemical equation. See, left hand side is representing the starting materials of a reaction, and the right hand side is representing the ending materials of the reaction, isn't it? So, if the starting materials are equal to ending materials with respect to mass, of course it means the reaction is following law of conservation of mass. That means nothing is disappearing, neither being created, isn't it? So, the equations in which LHS is equal to RHS are called as balanced chemical equations. But then, there are certain other equations which are not balanced naturally. Naturally, they exist in raw form. They don't obey any laws of nature. And such equations are called as skeletal equations. We call them as skeletal equations. Yeah? But then what are skeletal equations? In practical terms or in easy words, skeletal equations are the ones in which left hand side contents are never equal to right hand side contents. So well, chemical equations are of two types. One is skeletal equation, other one is balanced chemical equation. Skeletal equation is in which left hand side and right hand side are not equal. It doesn't follow law of conservation of mass. But then coming to balanced chemical equations, it is perfect, ideal, it follows law of conservation of mass, and then it has left hand side and right hand side entities equal to each other. This is the classification. But what has to be done with these skeletal equations? Can we leave them as it is? Can we leave them violating the laws of nature? No, we cannot leave them. Then what should we do? Should we delete them? Should we forget about them? No, we have to make them obey law of conservation of mass. But then how do we make them obey law of conservation of mass? That happens by a phenomenon called as balancing chemical equation. We call the phenomena of converting skeletal equations into balanced chemical equations as balancing. How many of you already have heard about balancing chemical equations, which is one very crucial topic as far as we talk about class 10 and class 11 also. Yeah, so the conversion of skeletal equation into balanced chemical equation is called as balancing the chemical equations. But then why should we actually do it? Why should equations be balanced? Why should we balance equations? What happens if they are unbalanced? I'll tell you what happens. See, for example, the same concept I'm teaching you in other way. For example, you are talking about one normal basic chemical reaction that happens. Say, you are talking about calcium carbonate getting converted into calcium oxide and carbon dioxide. Okay? Now, what if this equation is not balanced? You know what does it mean? You know what does it mean if an equation is not balanced? It means that if you are using 100 grams of a reactant, you will get some 1000 grams of product and some 2000 liters of carbon dioxide. Out of 100 grams of a starting material, can you get such huge quantities? Can you? Why? I'll tell you a little more simple example. We all cook rice, isn't it? We all cook rice, yeah? So, if you have taken some 50 grams of rice and if you have cooking rice is a chemical reaction, right? So, after cooking, all of a sudden, does it get converted into some 2000 grams of rice? Does it? There will be a little change in mass, that is because water is added, right? Otherwise, can we do this? That means these are the examples of equations which are not obeying law of conservation of mass. Law of conservation of mass is a fact. It says that you can't make a matter appear all of a sudden. At the same time, no matter in the world can disappear. Now, for example, if you have some 10,000 or say some 1000 liters of milk, if you have 1000 liters of milk and you just have warmed it, not even boiled and evaporated, can you find a drastic change that it got converted into some 100 milliliters of milk? Can you see the whole entire volume of milk disappearing? It's not evaporating, it's not boiling off. You just have warmed it. Can you see a drastic change in the mass? Can you see things disappearing all around you and appearing all of a sudden? No, right? It's never possible. That's what law of conservation of mass is. Nothing can appear and nothing can disappear. No matter can be created, neither be destroyed. And if this is the fact, that fact should be applicable to the chemical reactions also. And in mathematical terms, we are putting it on the paper. Every reaction, every change and every matter that is there in the universe should obey law of conservation of mass. That is the fact. Nothing can disappear and nothing can appear. And reactions also follow the same law, and that following same law is nothing but balancing chemical equations. Right, guys? So this is why we have to balance chemical equations, because it all runs on the facts. It's not some magic that something disappears all of a sudden and something appears. Right, guys? Are we clear about what are balanced chemical equations, what are skeletal equations, and why should we actually take this job, or why should we actually do this? Balancing chemical equations is a task, right? Why should we do it with no reason? Are we clear? Is there anyone who has a doubt so far? Yeah? That's great. That's great. Now, we are talking about chemical equations and its characteristics. After that, we spoke about chemical equations, types of chemical equations, and why should we balance chemical equations? What is law of conservation of mass? Let me tell you, this is all background work for one important step that we are taking now, and that important step is balancing chemical equations. Yeah. Now let me ask you something. How many of you already have attended my webinar on balancing chemical equation? How many of you have done it? Okay, 1, 2, Arman, 3. Okay, only 3 of you in the class, is it? No one else. So I asked you just out of my curiosity. It has no point with my class which is going on. If you have attended, you are going to listen to the same or listen to something better again now. If you have not attended, you are too lucky. You are going to learn something with a fresh mind. Yes, guys. So we are going to learn balancing chemical equations now. I'm telling you well in advance. Guys, this balancing chemical equations is something which is related to practice. You would have to practice along with me. and only then you will get excelled in this. Otherwise, if you are just watching it like a movie, staring at my face on the screen, you're not going to get benefited. You can aramse leave the class, go sleep. Please get a pen and paper if you don't have it even now. Yeah, and when we are learning balancing chemical equations, you got to write down the points which you find important, and you also would have to practice along with me. Yes guys, are we clear with what we have to do? That's good. That's good, Alagu. Right? That's cool now. So if we all have a pen and paper, let us start doing it. This balancing chemical equations, I'll tell you. If you look at NCERT, you have some 9 steps. You look at SCHAN, you have more than 9 steps or something, yeah. But I have summarized all the steps that are essential for you to learn balancing, and I have made it into 3. So according to our class, we have only 3 steps, and we have to remember 3 rules to learn balancing chemical equations. I don't find I don't find these 3 steps are too complicated or something. It's very easy, it's very funny. But you need 2 qualifications for this. Qualification number 1. I'll ask you, you should honestly say if you know it or not. Okay? Qualification number 1. You should know tables till 5. How many of you know? Table 1, 2, 3, 4, 5. Okay, very good. Smart students I have. Qualification number 2. How many of you like solving puzzles? Number puzzles? How many of you like solving number puzzles? Yeah? Well, that's great. If you have solved those crosswords of numbers and puzzles and all in your childhood, must be in class 2 or 3. If you have done your homeworks perfectly, today it is going to be of some use to you. Yeah? Right, that's great. Now let us start. Let us understand how to balance a chemical equation. So for balancing chemical equations, as I told, there are 3 steps needed and there are 3 rules to be followed. Step 1, 2, 3, rule 1, 2, 3. Let us not study the steps and rules so like this, like a mugging up thing. Let us take one equation and let us implement them. Okay. So there is an equation on the screen. Please make a note of this equation. H2 plus O2 gives H2O. I know it's a very simple equation, very basic equation, but then I have taken it because we are the learners now. We are just starting off with balancing, right? So well, have you all made a note of this? Yes? That's great. That's great. Now, the very first thing when you look at the equation you have to see is which is the right hand side and which is the left hand side. The right hand side is something which is there on your right hand side. The left hand side is something which is there on your left hand side. I see some of you sending me a balanced chemical equations like, well, I don't want to take your names right now, but very good guys. But let us do it for everyone in the class. Well, the left hand side is here and the right hand side is here. We identified it. The second one, check if the reaction is already balanced by chance. Check if it is already balanced. But how do we check? What is balanced chemical equation? It is when left hand side entities are equal to right hand side entities, right? So let us count the number of atoms on both the sides. Okay. What all do we have on the left hand side? On the left hand side I have hydrogen, I have oxygen. But how many? How much? How many hydrogens are there on the left hand side? There are 2 hydrogens, right? But how do we get to know the number? I hope you all remember a concept called as atomicity. What is atomicity, people? Atomicity is nothing but the number of atoms present in one molecule. Correct? Do you all remember atomicity? Atomicity is number of atoms present in one molecule, and it is always represented as a suffix at the bottom of the chemical formula. Since we are talking about H2, see, this is 2. In the subscript, just below the chemical formula on our right hand side, atomicity will be there. Atomicity of hydrogen is equal to 2. What is atomicity of oxygen? Can I see your responses, please? Atomicity of oxygen 2. That's great. Phosphorus? Phosphorus is 4. This way, whatever number of atoms are there is represented as atomicity. Now, one important thing that you should keep in mind is here. What if you have some number before the chemical formula or before the molecular formula? You call this number as coefficient or number of moles. We learnt it in mole concept class 9. Yeah, this is called as number of moles. And whenever you have some number, make sure you multiply atomicity with the number of moles. So 2 into 2. 2 into 2 is how much? 4. So totally I have 4 atoms of hydrogen here, right? We should multiply them, not add. Remember, we should multiply them. Yes, in balancing chemical equations, we never use additions. We only use multiplication, right guys? Now that way, please let me know how many oxygen atoms are here. 2 or 3 has how many oxygen atoms? How many? Oh God. Only Aditya responded correct, and after Aditya, Jahnavi, okay, Alagu, Vaishnavi, Anirban. That's good. It has 6. Those who answered 2 and 3, please listen to me carefully one more time. You have atomicity. Yeah, write it down first. But then, how many such species do you have here? You have a number before it. You got to multiply 3 into 6, right? Sorry, 3 into 2. 3 into 2 is how much? 6. If you have a number before the chemical formula, make sure you multiply that number with atomicity to get the number of atoms. Are we clear, guys? Those who have got it wrong, are we clear? Yeah, that's great. Now let's get ahead and see how many atoms of hydrogen and oxygen do we have. How many hydrogens? 2. And how many oxygens? 2. One more thing, what if there is no number? If there is no number, ignore it. Don't worry about it. Yeah. Now, on the other side, right hand side, again hydrogens and oxygen. How many hydrogens? 2 hydrogens. And how many oxygens? What if there is no number at the subscript? If there is no number, take it as unity, 1, the basic mathematical rule, right? So now check the number of atoms on both the sides. You have 2 hydrogens and 2 hydrogens on both the sides, equal. But look at oxygens, 2 oxygens and only 1 oxygen on other side, which is not equal. Now see, there were 2 oxygens initially, but after some time, 1 oxygen disappeared. Is it following law of conservation of mass? It is not. It is violating law of conservation of mass, isn't it? Yeah. So we have to make it obey law of conservation of mass by equalizing the number of oxygens on both the sides. Yeah. This is the first step. Count the number of atoms on both the sides and check if they are equal or not. If they are equal, my dear, you are lucky. You don't need to balance it. You can just leave it. But then, if it is not equal, you call the equation as skeletal equation. You have to balance it. So this is the first step. Let me go back to the table and show you. Step 1 in balancing chemical equation is count the number of atoms on both the sides. What do I mean by both the sides? Both left hand side and right hand side. Now, coefficient is applicable to all the atoms of the molecule. Draw a box around the molecule to avoid confusion. Hold on. If this statement is confusing you, I'll tell you what it means. Now, how many hydrogen atoms do you have? You already have answered it. It is 2 into 2, 4, right? How many oxygens do you have now, right now? How many oxygens? 2 oxygens. Very good. See, this is the molecular formula. Whatever coefficient you have, this is applicable to all the atoms present in the formula. If you are confused, please draw a box like this around the molecular formula, right? So the coefficient is 2 and the number of oxygen atoms is 1. Totally 2 oxygens is there. That is what this rule means. Always remember this rule because we get confused most of the times. Yes, that is about the first step. Are we clear about step 1? Should we get ahead? Should we? Yes? Right, that's great. Now let's go to the second step. I'm writing the same equation again. H2 plus O2 gives H2O. Yeah. And hydrogens, oxygens. Hydrogens was how many? 2. And oxygens is 2 again. On the other side, hydrogens is 2, oxygens is equal to 1. Look at it carefully now. Which is not balanced? Oxygen path is not balanced. So we have to balance it. Okay. On which side the number of oxygens is less, identify that side. Obviously, on right hand side it is less, right? Only 1 oxygen is there. But now, how many oxygens? I mean, what is the target number of oxygens now? How do I equalize? Look at the other side. There are two oxygens. I anyhow want two oxygen as the answer, right? Yeah. Target is to get two oxygens. We already have one oxygen. Remember, no additions. Only and only multiplication. You cannot use any other function other than multiplication. So, this one existing number of oxygens should be multiplied with some number. Your wish, any number. But your answer should be 2. Am I clear? You can use only multiplication and your answer should be whatever number is there on the other side. You can place any number in this blank or in this place. Yeah. Which number can you place? Can I take some 10 here or 5 or some other weird number? No, that's why I asked you. If you know tables, you are done. Now your answer should be 2. You should multiply some number with 1. Which number could you multiply? Only 2. 1 into 2 is equal to 2. Right? Yeah. So now if you can multiply the number of oxygens on the right hand side with the number 2, you will get the oxygens balanced. Okay, this is what the maths is. But we have to now make the same change in the chemical equation as well. But how? Take the number which you have used to multiply, place it as coefficient. I repeat, place it as coefficient on the side of right hand just before oxygens. Why on the side of right hand? Because I'm making this multiplication and all on the right hand side. Yeah. So whichever side you are making the multiplication, on the same side of the equation, you should apply the changes. Why only before oxygen? Hey, come on, I'm just multiplying oxygens, right? So we have to make changes before oxygen only. Yeah. So now let me go to the equation. This is the chemical formula, H2O. I have to use this number 2 as coefficient. Coefficient means whichever is present before the formula, right? Okay, this is H2O and before the formula it has to be placed. Remember, only as coefficient and only before the formula you can place this number. You cannot do this inside this box or at the subscript or wherever. We just have to place it as coefficient. Coefficient is something which is present before molecular formula. You have any confusion in identifying the formula, draw your box this way. Confusion gone, right? So now what did we do? We have made a change in number of oxygens. Okay. Now freshly count the number of oxygens. It is 2 into 1, 2 oxygens. Yes, somehow oxygen balanced. But then my dear students, please count the number of hydrogens on the right hand side now. How many hydrogens do we have? I want to see everyone answering this question. Well, that's great. All of you who answered so far are correct. I didn't find even one person gone wrong. You all are right, my dear students. See, you have 2 as coefficient and you have 2 hydrogens. So the total number of hydrogens now is 4. But how many do we have on the other side? We have only 2. It got unbalanced. What should we do now? Nothing to worry. Let us balance hydrogens. But how? On the right hand side, I have 4 hydrogens. On left hand side, I have only 2 hydrogens. So somehow I want to get the answer as 4 hydrogens. Yeah, are we clear with this point? Now, but how do I get it? I can use only multiplication but nothing else. So I want the answer to be 4. I can use only multiplication and I have to bring some number here. Which number? Can it be 5 or 4 or 3? We all know 2 table. 2 into 2 is equal to 4. 2 2s are 4. We have been marking this up from our first grade, isn't it? So 2 into 2 is equal to 4. Okay. This is the number which we used to multiply. Take the same number, place it as coefficient on the left hand side and before hydrogen. Why on left hand side? Where are we making these all changes? On the left hand side, isn't it? And why only before hydrogen? Because we are making this all happen with hydrogen. So before hydrogen. Well, where can I place before hydrogen? Can I place it somewhere as the power? Can we do this? No, we cannot. Always the number should be placed as coefficient. Yeah. Coefficient means something which is present before the molecular formula. right? Now count the number of hydrogens. 2 into 2, 4. And on other side also 4. Oxygens 2 on both the sides. So finally, the number of hydrogens and oxygens on both the sides is equal. And we call it as balanced chemical equation. Let me write it with a thick pen. 2H2 plus O2 gives 2H2O. This is balanced chemical equation. Now count the number of hydrogens. 4. Oxygens 2. Hydrogens 4. Oxygens, I find only one oxygen here. Is it balanced, guys? Is it balanced? Yes or no? It is balanced. How? Because there is a coefficient. Count the number of oxygens along with coefficient. It is equal to 2. So this is a balanced chemical equation now. Let us go back to the table and see what is step 2 and step 3. Step 2 is equalize the number of atoms on both the sides. But how do we do it? By additions? No, only by multiplication. After this, step 3. Change the coefficients in the equation according to the number that we used to multiply. And you can change only coefficient but nothing else. Guys, with this, did we use all the 3 steps to balance the equation? Did we? Yes or no? Yes. And did we apply all the 3 rules? Did we skip any rule? No. So these are the 3 steps and these are the 3 rules which are essential to balance any chemical equation in the universe. Yeah, anything. And if you get perfect in these steps and rules, you can balance equation in minute of time. You don't need more than 60 seconds to balance any equation with a good practice. Now tell me people, how many of you could understand? I want you guys to be honest. How many of you could understand? How many of you? Yes, that's good. That's good. So don't be so happy because I have given you the most basic equation. Now let us take one more equation and balance it. Yeah, right? Let us take one more equation and let us balance it. Let us practice few more with increased complexity so that we can get a good practice. Right, guys? So, my dear students, remember one thing. Right now, we are learning only about how to balance chemical equation. The physical states and all we are not dealing with right now. So, let us get perfect in the balancing first and then let us apply physical states. Yeah? Right? Yes. So, there we go with the next chemical equation. Let me tell you something. Whatever steps are there on the screen right now, just go through these steps, go through the rules. If you want, take a snapshot of it and keep. If you want, make a note, whatever. I'm just closing this table. For the upcoming equation, I'll not show you the table. You would have to try it doing by yourself. In between, I'll give you some hints. Yeah? Will you be ready for that? Yes? That's good. That's good. Let me revise them. Let me just brief you. Step 1, count the number of atoms on both the sides. Step 2, equalize the number of atoms with the help of multiplication. And step 3, change the coefficients with the number which you have used to multiply. These 3 steps, that's it. I too hope such simple equations come in the boards, but then unfortunately they don't. Yeah? Kanishka, definitely, please do remind me at the end of the session, I'll give you. Yeah? Right, there is an equation on the screen. CH4 plus O2 gives CO2 plus H2O. Please make a note of the equation. Yeah, I hope you are done noting down equation. Step 1, count the number of atoms on both the sides. Count the number of atoms on both the sides. Samyukta already has given a balanced equation. That's cool. Step 2. Identify the ones which are not equal and start equalizing them with the help of multiplication. That's good. Niharika, correct. Anirban, correct. And step 3. Whichever numbers you have used to multiply, please use the same numbers to change the coefficients in the equation. Right? Are you all done? Let me know those who are done through the chat box. Janavi, can you not hear? Please refresh, my dear. Please refresh. Because this time I have not done anything? Okay. Done. Got it. Okay. I see most of you saying done. Now let me show you how to balance and tell me if you have got the correct one. This is the number of atoms on both the sides, and now I have to balance hydrogens and oxygens. Let me start with hydrogens. I want 4 hydrogens as answer, and I can use only multiplication. So which other number is feasible? Obviously 2 is feasible, right? So let me use the same number to change the coefficient on which side? The right hand side before hydrogen. So there I go. 2 into hydrogen is equal to 4, but then look at the number of oxygens. Now it has become 2 oxygens plus 2 here. Totally 4, correct? Now the fresh count of oxygens is 4, and on other side I have 2. I totally want 4 oxygens and I can use only multiplication. Which other number is feasible here? Again 2. 2 into 2 is equal to 4. Now the same number which I used to multiply should be taken and it should be placed before oxygens on the other side. Well, there I go. Now the fresh count says that all the number of atoms on both the sides is equal. The balanced chemical equation is CH4 plus 2O2 leads to formation of CO2 plus 2H2O. How many of you got it correct? Please be honest, and how many of you got it correct? Yeah? Okay. Is there anyone who missed it? You all know, right? Your messages are only visible to me. Nobody else in the class can see your messages, right? You all know it, correct? So your responses are highly confidential. Don't worry about it. No one in the class who missed it, right? Okay, that's great. I'm glad if none of you have missed it. And for those who have actually given the equations in the chat box, the balanced equations in the chat box by typing them, I really appreciate your efforts, my dear students. Thank you so much for your efforts. Now I have one other question for you coming up. Please go through this question. Please go through the options also carefully. The answer for this question is law of conservation of mass. Law of conservation of mass is something which deals with the balancing chemical equations, mass, creation, destruction, and conversion of one form of mass into other. There you go with the answer on the screen. Yeah. So everyone in the class, 100% of you have responded it to be correct. That's good. Now I have one more question which is related to balancing. So be ready with your pen and paper. There you go with the question on the screen. Hurry up guys, try to balance it. I'll be launching a poll. Balance it, identify the correct option and be ready. Need not to be posted in the chat box. Identify the balanced chemical equation and be ready. Right, unfortunately this time I have 3 students who got it wrong, but that's okay. My dear students, I hope you tried balancing the equation. Those who have chosen the wrong option, can you please let me know if you have tried balancing? Are you stuck with it? You want me to explain how to balance it? You want me to do so? Please let me know. Hey, I don't see any response on the screen. Okay, my dear, are you done? Okay, right then. Let's get ahead with one more question. If anyone is stuck with the last question, please let me know. There you go with the next question. This is also being discussed in the class. That's good. That's good. If you're done with the last question, I see responses already in the chat box. Few of you had chosen a wrong answer for this question. My dear students, it's very, very, very important. Remember, reaction conditions such as temperature, heat, electricity, catalyst, pressure, these all are represented on the arrow mark. Yeah, you remember we have studied it in the characteristics of the chemical equation. Where is this gone? I think it is in slide number 5 or 4. Yeah, take a look at this. Yeah, take a look at 4th point. Take a look at 2nd point. Yeah, right. So we always have to represent any reaction condition. Any reaction condition such as temperature, pressure, catalyst, or electricity or delta symbol, these all things are the conditions for a reaction to happen, right? You should use them on the arrow mark. Physical state also, look at point number 3. Where did we represent physical state? Physical state is represented in the bracket, right, just after the molecular formula. If you have had listened to me carefully at this slide, you wouldn't have made this mistake. Yeah, right? Those who have chosen a wrong answer, is it clear now? Yes or no? Who have chosen wrong answer? I'll not take out your names, don't worry. Those who have taken the wrong option, are we clear now? That's good. Are we clear now? Very good, very good. Making mistake is always fine, but then we should learn out of the mistake, right? Well, we do not represent physical state. Then where else do we represent physical state? As shown on the screen, we represent physical state as a bracket or subscript just after the molecular formula. Yes? Now, let us go to the next question. But before we could go to the next question, we need to learn a few more points. We just now have learned how to balance chemical equations. So let us practice one more chemical equation, not one more, two more chemical equations. Then let us talk about a few more new points as well, right? And this time I'm not going to help you much in balancing. You are trying to balance it, yeah? Right. The correct option is option D for the last question. It is physical state. So those whoever have chosen option D, you are correct. Okay. Now let's go with the next question. Are we all ready to balance one more question? Are we all ready? Yes, that's good. I'm going to give you a little complicated question, so be ready for it. Be alert. The question is, balance this chemical equation, and the chemical equation is HCl plus MgOH twice leads to formation of MgCl2 plus H2O. Guys, you have 1 minute of time. Exactly 1 minute of time. Hurry up. I want to see the balanced equation in the chat box. I'm not going to give any hint. So you got to balance it by yourself and you have 1 minute of time. Let me see how many of you would get it correct. Please do not copy paste it from somewhere because I'm not giving you some beautiful gifts for this. You don't need to cheat me and cheat yourselves, right? So try to balance it. If you get it, post the answer. If you don't get it, nothing to worry. I'll explain you again. Yeah? Niharika is done, and Niharika, you are correct, but then there is one slight mistake on the right hand side. Please check that. Samyukta is done and Samyukta is correct. Purvi, please send me, you're done, right? Please send me the equation. Niharika, that's good. You have corrected now. Who else? Only girls. Where are boys gone? Where are the boys in the class? That's good. Alagu, correct. It is correct. I'm not revealing the equation because I don't want others to copy down the answers. So, only a few. How many? 1, 2, 3 of you have sent the equation. Purvi, I'm waiting for your equation. You said you're done. I'm waiting for the equation. Anirban, there is a mistake on the right hand side. There is one mistake on right hand side. Please verify. Arun, perfect. Correct. Next, Purvi, done. That's good. Who else? Let me see the time. It's been more than 1 minute. Oh my God. Only a few of you could answer. How about rest of you guys? Are you doing? Those who could finish it in less than 1 minute of time, I really appreciate. You are doing very, very good. Those who are still doing, that's fine. That's fine if you are late by a few seconds. It's not a serious problem. And those who are stuck up somewhere, let me quickly revise. Okay. Now, first thing, we have to count the number of atoms on both the sides. Hydrogen, how many? 1 hydrogen here, 2 hydrogens here, right? Totally 3 hydrogens we have. Chlorines, 1. Magnesium, 1. And oxygen is equal to 2. You see this? Whenever you have something out of the brackets like this, according to maths, whatever is there just out of the bracket is applicable to all the entities inside, right? So that means you have 2 oxygens and 2 hydrogens here. That's what we did. Correct? Now, on other side, magnesium, let me write it in the same pattern. On other side, hydrogen is equal to 2. Chlorine is equal to 2. Magnesium is 1 and oxygen is equal to 1. I hope everyone is clear so far. If you are not, please help me understand through the chat box. Yeah. Now let's go to the next one. What all is not balanced? Hydrogen is not balanced. Chlorine is not balanced. Oxygen is also not balanced. Let us start balancing with chlorine. I have 2 chlorines on the left hand side. Sorry, right hand side. You know what? You can start balancing with anything, but try to choose the simple one. See, hydrogen is 3 and 2. You know, one odd, one even. It's difficult to bring a balance between hydrogen, right? But chlorine, I have 1 chlorine and 2 chlorines. It's easier to get chlorine balanced first, right? That's why I have chosen chlorine. It's a tactic. Please remember this. Now, I want 2 chlorines. I can use only multiplication. So obviously the number here should be 2, right? So now use the same number as coefficient in the equation. Look at the count of hydrogen. Now you have 2 hydrogens plus 2. So it is 4 hydrogens. Both the hydrogen count is even now. It's easier for us. I want totally 4 hydrogens and I can only and only multiply. So it has to be into 2. 2 into 2 is equal to 4. So let me take 2 hydrogens here. But it has an effect on oxygen count, correct? So how many oxygens do we have here? 2 oxygens. Luckily, automatically balanced. Magnesium is anyways balanced. So the balanced chemical equation right now is what? Balanced chemical equation is 2HCl plus MgOH twice leads to formation of MgCl2 plus 2H2O. Armandas, please do not post the same answer for multiple times. How many times? You have posted it for more than 10 times. Please don't do it. It will hinder the messages of other students. I'll just see only your messages, and if anyone else is asking a doubt or a question, I will not be able to notice it. So anyone, not only he, anyone in the class, please post your response only once. Unless and until I ask you for the second time, don't do it. Okay? Right. So how many of you in the class were stuck up in balancing? How many of you in the class are stuck up in balancing? Take a look at this equation. Please tally your equation. Yeah? Did you get the same one? Right? That's good. Anyone in the class who was stuck up? Arman, how about your equation? Could you tally? Yes. If you have got it, if you are not stuck, then that's cool. If you are late by a few seconds, it's totally fine. No problem. You will lessen the time with the practice. Yes? It's okay if you're late. Doesn't make a big difference. It is just the third equation, right? Yes, guys, this is how we balance chemical equation using 3 simple steps. If you go through NCERT, the same 3 simple steps are elaborated to 9 steps or something. So you don't need to worry that NCERT has 7 or 9 steps and here we are dealing only 3 steps. Would I get full marks? You will get absolutely full marks even in your board exams. Don't worry. The steps which we are doing now, it's a just consolidation of all the 7 steps. Okay? Nothing to worry. Nothing to worry at all. Right, guys? Now, if we have learned balancing chemical equations, let us practice one more complicated equation before learning something else. Yeah? And this time, let me see how many of you have reduced the time to balance it. Okay? Are we all ready? Yes? That's cool. Let us start. The equation is on the screen. I'll be writing it on the screen now. Yeah, the equation is HNO3 plus ALOH thrice leads to formation of, let me write it properly. It leads to formation of aluminium nitrate, which is AlNO3 taken thrice plus H2O. Your time starts now. It's 8:08. Let me see. Armandas, you have, rest of you keep doing. Armandas, you have doubled it. Okay, that's a good point. Let me just tell you. Not only you. Give me one moment. Please complete this equation. I'll explain this point to every one of you. Okay? Complete this equation also. Whoever is done, you can please let me know through the chat box and then you can type in the equation. First, let me know whoever is done within 1 minute. I'm not giving you hints also because this is the fourth equation. Yeah, I want you to learn it. And if you are stuck up, confused or any problem, don't worry, don't panic. I'm coming to explain again. So nothing to worry. Right, guys. So those who are still doing, keep doing. And for those who are stuck up, no problem. No problem if you're stuck somewhere, I'm coming. Yeah. So this is the atoms which we have on the left hand side. Hydrogens, nitrogens, oxygens and aluminium. Yeah. Now, those who answered correct, please respond in the chat box. Yeah. How many hydrogens do we have on the left hand side? We have 3 hydrogens here. And along with that, we have 3 hydrogens here. Correct? Totally 6 hydrogens. Am I right? Yes. And then how many nitrogens do we have? We have 1 nitrogen. Hey guys, I already have written the answers. Please don't focus on it. Those who are stuck up, please don't focus on the answers. Just focus on the way we are balancing. Okay? Nitrogen. There is only 1 nitrogen. And oxygen, how many? 3 oxygens here plus 3 here. 6 oxygens and aluminium only 1, right? Let us look at the other side. The other side, hydrogens, 2 hydrogens only, correct? Hydrogens only 2, right? Now, on other side again, how many nitrogens do we have? We have 3 nitrogens, correct? And oxygens, how many? 3 into 3, 9 oxygens. Now, aluminium, only 1. Are they correct? Got up with it? Okay, fine. Those who are stuck up, those got it, that's fine. Now, we have to balance almost everything except aluminium, right? Let us start balancing. With hydrogen, I have 6 hydrogens and I want the same 6 on other side also. I have 2, I can use only multiplication. Use some number here. 2 into how much is equal to 3? Sorry, 2 into how much is equal to 6? I told you the answer also. It is 3, right? So 2 into 3 is equal to 6. Now I need 3 to be placed before hydrogen. Yeah? Now, oxygen count also differs along with it. How many oxygens do I have here? 3 into 3, 9 plus 3. 9 plus 3 is? Guys, am I audible? Am I audible and visible? That's great, that's great. So how many oxygens do we have here finally? 9 plus 3, totally 12, right? Now, on other side, how many oxygens do we have? Only 6, correct? We need 6 more oxygens, that means totally 12. I can use only multiplication, take some number. You can take which number? You can take which number? You can take number 2. But then you know what? You cannot take this number 2 at one among these places, correct? That means you have 2 oxygens. So this way is making things complicated. Then what you have to do is stop balancing oxygens and go to something else which is simple. Okay? Whenever a situation comes where you have to do a lot of work balancing some atom, just pause it and go balance some other atom and come back. Okay? Now let us for a while stop balancing oxygen, come back, balance nitrogen. Okay? Nitrogen I have 3 on other side. So here also I want 3. I have 1. So I should multiply with which number? I should multiply with number 3. Correct? Hey guys, am I audible? I am, right? Am I audible? Yes, that's cool. So this number has to be placed before nitrogen. Nitrogen is here, so place it before nitrogen. Nitrogen count is balanced. Now, this has an effect on oxygens also. Check now. I had only 3 oxygens from this end. Now, I have 3 into 3, 9 plus 3. 9 plus 3 is how much? Is it not 12? It is 12. Our oxygens automatically got balanced, right? Whenever you are stuck up with balancing one particular atom, don't crack your head there. Just pause it for a while, go to the next atom, balance it and come. By the time you balance other atoms and come back, the atom which was troubling you would be easy or would be auto-balanced this way. Yes, guys. So the entire balanced equation is 3HNO3 plus AlOH twice, giving AlNO3 thrice plus 3H2O. Right, guys? Are we clear with balancing this particular equation? Is there anyone who is stuck up? But then remember one point, my dear students. Just practicing 3 or 4 equations and feeling that we have learned the concept is not right. Balancing chemical equations is something which troubles you a lot. Today you have learned it, and if you don't practice and come back to the next class, you would have forgotten everything. Believe me, this comes only with the practice. You should be balancing equations on everyday basis. Every day at least one equation should be done. Yeah, only then you will get a very good grip over this concept. Yeah, so from now keep balancing the equations. Yes, guys? Yeah, right. Now that we have learned much about balancing, let me tell you one more thing. Whenever we are writing any equation here on in our boards or in our unit test or exams or whatever, ensure that you write only balanced chemical equation. And the second point is, a balanced chemical equation is complete only when you write the physical state. What is physical state? I hope you remember. Physical state is nothing but physical state of reactants and products. Yeah, we have to write if it is solid, liquid or gas, correct? Only when we write that, the balanced chemical equation is actually complete. So you need to learn the physical state of reactants and products. For now, right now at class 10 CBSE level, we will not be aware of physical state of all the chemicals, but we would have to get a practice of it. How? Whenever you're learning equations, concentrate on the physical states also. Other than that, I will also give you a notes kind of thing which has some techniques to understand the physical states, okay? But then, please do remind me after this class immediately in the WhatsApp group. Otherwise, I'll forget because I'll have many classes in a day and I tend to forget many things after the class. So please remind me to give you a notes of how to identify the physical state of matter. Okay? Yes, only Samyukta says okay. Where are others? Everyone in the class, right? That's good. Please do remind me. So with the help of that notes, only to some extent you can understand the physical state. But then you will completely understand only when you study the reactions, only when you observe a lot of reactions. Yes, guys? So whenever you're writing a full, completely balanced chemical equation, ensure you write physical state also. Yes? Right. Since we are talking about the physical states, let me tell you a few points here. Point number 1. We all know solid, liquid, gas physical state. Nothing new in that, isn't it? But in chemical equations, we use some other terms like AQ. The full form of AQ is aqueous. Whenever you add a substance to water, maybe you add sugar to water, you call it as aqueous sugar solution. If you add salt to water, you call it as aqueous salt solution. This way, whenever you dissolve a substance into water, you call it as aqueous. Yeah. So aqueous is representing something dissolved into water. Yes. Remember all of you, this is one important physical state. Number 3, PPT. What does it mean? What does it represent? It represents precipitate. What is precipitate? Precipitate is something which is insoluble. Yeah. Insoluble material which is, remember, precipitate is always a product. Precipitate is never a reactant. Insoluble material which is formed after reaction is called as precipitate. Yeah. Right, guys? Now, third one. If it is solid, you represent it as small s, liquid small l, gas small g. These are the physical states which we have to understand. Right, guys? Are we clear so far? Is there anyone who has a doubt in this? Is there anyone? No, right? There you go with the question on the screen. Please go through the question and go through the options as well. I'll launch a poll for you. Please go through the question and options. Okay, MD Tahur already have answered. Rest of you, hurry up, my dear students. Please go through the question and go through the options carefully. By the way, Tahur, you're correct. Good. Yeah, if you are done going through, let me launch the poll as well. But help me understand if you are done with it. It's a pretty long question with bigger options, right? Don't worry, take your time. Those who are saying wait, take your time. I have 10 more seconds of time for you. If you are done, be ready with your option because I cannot read out the options for this question. So be ready with your option, well prepared. Yeah. So well, there you go with the correct answer. Let me read the question and let me explain the answer as well. The correct equation with state symbols for the following solutions. They said solutions of barium chloride and sodium sulfate in water. Whenever you dissolve something in water, what do you call it as? You call it as aqueous, right? So observe the reactions and products, reactants and products. Which among these all is balanced? The first one, you have two bariums on left hand side but only one on right hand side, not balanced, right? Second one is balanced, but then NaCl physical state is correct, but then which is incorrect here? BaCl2 plus sodium sulfate plus BaSO4 plus NaCl. NaCl is not balanced, right? Now in third one, it's not balanced again. Only the fourth equation shows a balanced chemical equation, correct? So they have asked you to be perfectly correct with balancing and physical states. So option D is correct. Is there anyone who did not understand why is option D correct? Is there anyone in the class? Totally 7 plus 14 plus 7, 28% of you have chosen option D. I wanted to, okay, that's fine. That's good then, that's good. If you had any confusion with the options, I believe it's clear now. Why can we not write it as 2BaCl2 plus 2Na2SO4 plus giving 2BaSO4 and 4 NaCl? Why can we actually not double the balanced equation and write it? Why can we not double the equation? What happens if we double? There is one other rule in balancing that you have to change the coefficients or you have to use the multiplications at the most minimal level. Yeah. Now see, in this equation, there is a scope that, let me just move this box somehow. Whenever you can balance a chemical equation with the minimal numbers, you cannot go beyond it. Yeah. So look at this equation option D. I can balance it with 1 BaCl2, 1 Na2SO4. I should stop at that minimum number. I can't take it to be double, triple or whatever. Yeah. Always when you are using multiplication, make sure you use the minimum number possible. Am I clear? Yes. Yeah. Keep this point in mind. Is there any other doubt that you want to ask me? You can please ask me. Is there any other doubt? If not, I have one other important point to speak. So, if you have a doubt, please ask me your doubt. Guys, make sure you get all your doubts clarified. Make sure you don't remain with your doubts even after the class. Only then you can get benefited. See, at the end of the day, you should be benefited, right? So you will be benefited only when you ask all your doubts, only when you get all your doubts cleared and concept strengthened. Yeah. So in case you have a doubt, please ask me. If not, yeah, WhatsApp, I'm coming. Before that, there is one doubt from whom. Let me just go back and check. There is one doubt. Guys, before I could give you the WhatsApp number, let me quickly resolve this doubt also. Can we use L in place of aqueous? No. We cannot use liquid physical state in place of aqueous. Liquid is just a liquid. It not necessarily be water. It may contain water or may not. For example, oil is also liquid. Yeah. But then aqueous is something which for sure has water along with some other substance. There is a lot of difference between liquid and aqueous. We cannot interexchange them. Yeah? Right? That's cool. Any other doubt? And coming to the WhatsApp group, there you go with my number 7411963057. Please ping me on this number. When you ping me, please tell me your name. When did your batches start? Like, what is the first online class that you have taken with Vedantu? I guess 11th June, right? Yeah? Yes? Tell me, am I correct? Yeah. Tell me your name, tell me the batch, that 11th June, and tell me at what time your classes will happen, 7 o'clock or 5:30. Okay? I'll add you to the respective group. Yes? So I have posted my number in the chat box. Please take down the number. One more time, you want it, 963057. Make sure you note it this time. Yeah? Bye. Welcome everyone. Welcome. Bye-bye.